Hi, welcome to my presentation, Enriching Programming Student Feedback with Audio Comments. My name is Jake Ronzella and I'm from Deakin University in Australia. Let's start by looking at the research goals of this project. The first goal is to start looking at ways we can address the growing online cohort pain points experienced in the teaching and learning system, specifically in the learning management system. Especially in a discipline such as introductory programming, which is often documented as both difficult to educate students in and difficult to study in as a student. In our literature review, we identified audio feedback as a promising mechanism that we could replace the traditional text-based feedback we were using in our introductory programming units. There are a number of benefits identified in the literature of audio feedback. One of them is that it may be faster, something that's important to us, and another is that it helps increase the relationship development capability when we provide feedback to students. This is something that's really important for online students, as online students may never see your face, hear your voice as a tutor, and often they're engaging in a similar capacity to local students who get a lot more benefit. Let's explore the literature. There are many studies on audio feedback, with many benefits identified. However, there are few of these studies in introductory programming, if any. Furthermore, the implementation details of these studies is really important. A lot of these studies use external audio recorders, file managers, emailing audio snippets to students back to tutors as the mechanism for providing that audio feedback. And this introduces a huge overhead into that process. And this is really important for us because what we're trying to do in part of this research project is to validate the literature's findings that audio feedback is more efficient and apply that to introductory programming. I'm sure a lot of you have experienced how teaching costs are trying to be kept as low as they can while also balancing providing high quality formative feedback. The research contribution here that we wanted to look at was, do these efficiencies that have been highlighted in the research apply to programming education where we're dealing with complicated syntax, code, and programs? Let's start by taking a look at the implementation context surrounding this research project. Fortunately, we were using the Doubtfire Learning Management System, an open source LMS used at a number of Australian universities. It was originally developed and designed for programming, however it's used in many different disciplines now. And because it's open source, we were able to fork the project, integrate this feature into the system, and evaluate it. You can access the GitHub repository via the QR code on screen or just navigate to the GitHub link underneath. As a brief overview of the system, I wanted to talk about the three main components that tutors use to interact with the students. The first is the task inbox. This is where any items that come to the tutor for the tutor's attention will appear. For example, a new submission from a student or even just a new comment from a student. The main view is the task submission panel. This is where you can see the generated PDF showing off the student's code, multiple code files, Word documents, other PDFs, or even images. Finally, the task discussion panel. This is where the main interaction with the students comes from. Traditionally, Doubtfire supported text-based comments, and obviously in this project we incorporated the audio feedback, which I'll talk a bit more about soon, and there are many novel features included in the Doubtfire system to support the provision of formative feedback in a high quality and timely manner. When looking at how we implemented audio feedback into the system, we took a cross-platform, cross-browser, built-in approach. So no plugins are required, such as Adobe Flash, no external audio recording software is required. And to ensure this system worked cross-platform with all the major browsers, including Safari, it was actually quite a lot of technical work. We had to implement our own version of the Media Recorder API fallback for Safari, and we had to ensure that we could encode and decode all of the different browsers' built-in encoding methods on our server. But by doing this work, it meant that the system is fast and timely. No downloads, no external players, you can just record from the browser and play back from the browser. So with it implemented, we set about the research project. First of all, we looked at all the introductory programming submissions we had collected on the Doubtfire system, and we categorized them into the different ways tutors were required to provide feedback for the student. The goal here was to look at what are the different types of feedback we provide to students on introductory programming assignments. Now, yes, this may be specific to the style of introductory programming units we study at our university. However, we do believe this rough categorization is applicable to most introductory programming units. We then recruited introductory programming tutors, ideally those with experience teaching with Doubtfire. This was just to show that we were evaluating the introduction of the audio feedback tool rather than testing tutors in a whole new environment. There were 3 phases to the research activity that we took participants through. We had 8 participants for this study, however it was a very long 1.5 to 2 hour experiment. The pre-experiment interview sought out to collect expectations towards the use of audio feedback in providing formative feedback to students in introductory programming. The main experiment saw the interviewees sit through 8 simulated submissions across each of those previously documented categories. They went through this twice. The first time they went through the submissions, they were providing either written feedback or audio feedback. And the second time, they either had the introduction of the audio feedback tool taken away or provided to them. And it was a 50-50 split as to which track they were on. This was to ensure that there was no bias introduced with the order that the feedback was provided in and by what method. Finally, in the post-experiment interview, we sought to just collect reflections following their use of the tool. So let's look at some of the results. Well, with the expectations, 5 of the 8 participants expected audio feedback to be faster than traditional written feedback. However, most of the participants expected audio feedback to afford better relationship development. This is a key tenet of audio feedback, is forgetting all of the efficiency that you get from the communication method. The theory in the literature suggests that the affordances it provides when developing relationships with students is really important. These are the main results we found in terms of the efficiency when comparing the 2 forms of feedback, both written and audio, keeping in mind that each participant provided a total of 16 pieces of feedback across each of those categories twice. Now, if you go into the paper and you can look closely more at how each category correlates to each result set, we can start to see some trends, which I'll discuss more later on in the presentation. However, what I wanted to point out is that there are some categories where the feedback efficiency gains is quite significant, such as category C3, and there are some where it actually isn't, so categories like C4. Now, we do have an explanation for this internally. However, like most research, we would like to see either reproductions of these results or further research looking into it. And a quick look at the reflections. We had an increase in the number of participants that thought audio feedback is more efficient. And every single participant now thought, following the main experiment and using audio feedback in the learning management system, that audio comments are better for developing relationships with students. And like I said before, this introduces a huge number of benefits into the teaching and learning activity cycle. Now, onto the discussions. What we found is that audio and written feedback complement each other. It's not a case of one is better than the other. And the reason for this is specific to programming and maybe some certain other disciplines, but especially programming. And that is that when we're referring to code specifically, it's better to leave a written comment because you can have things like syntax highlighting on the code examples. And code is just something that we're trained to be able to read. So if you're going to provide some code explanation to the student, being able to type that code into the LMS and send that as a written comment, and then using audio feedback to kind of annotate and augment that example is where we can get the most benefit. But where your feedback is explanations and discussions, we found that the audio feedback is faster than written feedback. And that's pretty much across the board. So where you're talking about the code, audio feedback is seen to be faster in our results. However, it's slower if you're trying to kind of spell out code. So we saw some participants trying to do that. And actually, a few of the participants, even without any kind of training on this, just started typing the code in the experiment and then explaining the code with their voice. And we really do see this as where audio feedback sits for introductory programming. And kind of more importantly, tutors' perceptions to audio feedback was really, really positive after it. We did have some participants that were kind of nervous going into providing audio feedback, and this is something that you do need to keep in mind. So not everyone is comfortable with recording their voice. Not everyone is able to record their voice. You might have some impairments or disabilities, and that goes especially for the students too. So you do need to approach this with an open mind in terms of some of the reasons why audio feedback might not be always perfect. However, the perceptions and the relationships you can build with your students that you may never see face to face is really one of the core benefits. We introduced the audio feedback tool into the mainstream. So we submitted a pull request to the Doubtfire system and it was accepted. And at our university now, we've had over 3,000 audio comments provided. That it's including students and tutors. And we really see that, especially with online students, again, who you never meet, potentially you may never speak to, not only does it show the teaching team to be more human to the students, it's a reminder to the students that there's a human being on the other end of this system providing them feedback. It just increases the way that we can develop relationships, convey tonality with our feedback, and it can actually disarm some of the more tense conversations we have with our students. I think some of you may have experienced this, but I, as a teacher, when I'm providing feedback to students, sometimes it can appear to be quite cold to students, even if I'm in a happy mood, a good mood. Sometimes when we're just providing lots and lots of feedback, it can appear quite short. However, when you're using your voice, students can hear my tone, what I'm trying to convey, how I'm trying to build a relationship with them, and it really can be quite disarming. Thank you for coming to my presentation looking at audio feedback in introductory programming. Something I wanted to mention is that I also have a poster and a poster presentation in this conference, which looks at the evolution of this work that saw how audio feedback can be used to facilitate discussions within the learning management system. And one of the benefits of audio-based discussions is that we can introduce artificial intelligence to actually analyze the student's voice that we are collecting via the Doubtfire system over time. And we're actually introducing an approach to validate academic integrity based off the voice signature of the student participants in the discussion system within the Doubtfire system. So please check it out if you're here at the conference live, or if you're watching this in the future, try and find that poster. And yeah, thanks for coming to this presentation, and I'm really looking forward to the Q&A. Cheers.